Guys, please give me some time. I'll start. Okay, I just came. So please wait for like 5 minutes. Hi everyone. How are you guys? I'm really sorry, and thanks for waiting. Okay, so where were we? We were studying permutations, right? So did you guys try to?
Yes, sir.
Yeah. So did you guys try to solve problems based on permutations? Exercise 7.3. I suppose most of the problems you'll be able to do. Oh, what? You tried? Did you give it a shot? Something? Anything? Okay. We'll solve problems based on permutations. I'll share my screen. Just let me know whether you guys are able to see it or not. Okay. Okay. Acha, guys, is it okay if I extend the class till 7:50? Will that be okay with you guys? If anybody is having problem, please tell me now itself. I know I was late. It was my mistake. So can you please tell me if we can extend the class till 7:50? 1 hour only from now. Is that okay with all? Hari, Abhinav, Murli, Naveen, Jeffrey, Nidhi, Shrikriti,
Sir.
Okay, sir.
Shreya, will that be okay with you?
Yes, sir.
And Divya, biology 2. How about you? Let me know if it is too much, okay? So I just want to finish permutation today. All right, so today, yesterday, we did this problem, right? Yesterday we have done this problem, isn't it? Last problem was this. So after today's class, I suppose you'll be able to solve all the NCERT problem. Let me open the NCERT book first, okay? And we'll start to solve from there. So anybody is having trouble understanding permutations or our fundamental principle of counting? Is there any doubt or anything that I can help you with? Please tell me. It's fine. It's fine. Whatever problem you have, please tell me so that I can help you out with it. Okay. Okay. Okay, where do you get NCERT books from? Online, is it available?
Yes, sir. We have got PDFs also.
Okay, you have got. I had PDF, but somehow I'm not able to find it. Can anyone send me? Where is the book? Permutation, combination. Okay. I've got it. Okay. Just a minute. Just a minute. We'll start. Give me. Achha, is my voice clear? Because my internet is really slow, so I'm really little bit not sure whether it is okay or not.
It's clear, sir.
It's clear. Thank you. All right. We'll do problem number 5 of your NCERT book. Where is it? There's something wrong. Open page number, exercise 7.3. Question number 5. Okay, from a committee of 8 persons, in how many ways can we choose a chairperson and a vice chairman, chairman and a vice chairman, assuming one person cannot hold more than one position? Please solve this problem. Try this. Page number, your NCERT page number 148. 148, question number 5, exercise 7.3. Okay. So from a committee of 8 persons, in how many ways? So total 8 people are there, or 8 persons are there, and you have to fill 2 positions. In how many ways it can be done?
Sir, 56.
56 is really easy, right? That means, see, first, this is your first position, and this is your second position. First position can be filled in how many ways? 8 ways. Now that we cannot repeat it, that means whenever we are arranging, that means repetition is not allowed. So second position can be filled in 7 ways, because now 7 people are left. So 8 into 7 is how much? 56. Or you can also directly write 8p2. That will be equal to how much? 56. So 8 factorial upon 8 minus 2 factorial. So that will be equal to 8 factorial upon 6 factorial, or you can write 8 into 7 into 6 factorial divided by 6 factorial. This will be equal to 56. Okay. All right. So what is the meaning of NPR? What is the meaning of? Yesterday we have seen what's the meaning of NPR. Please tell me. Anyone? What is the meaning of NPR?
The number of permutation of n different things taken all at a time.
Not all. Is it all? That is NPN. NPN is, number of permutation of n different things, taking all at a time. Okay. and here taking R at a time. Okay, R number of permutation, we are like, when we are saying 8p2, that means it is arrangement of 8 different people, okay, taking 2 people at a time, right? That's the meaning here. Got it?
Yes,
Okay,
sir.
yeah, let's solve another problem. Let me take problem from somewhere else. All right, write down the problem. Okay, how many different words can be formed of the letter of the word? So the word letter is given MALENKOV. I don't know whether it makes sense or not. Okay, so you have to, how many different words can be formed by these letters? Okay, find out. If obviously repetition is not allowed, that means if one letter is used, next so it cannot be used again, right? So these are the letters given, and how many words with or without meaning can be formed? Anybody is having doubt understanding this problem? Anybody having trouble understanding this problem? Please tell me. It is fine. Yeah, what's the answer?
Sir, 8 factorial. Sir.
8 factorial. Okay. So how many letters are there in this word? 1, 2, 3, 4, 5, 6, 7, 8. Now these 8 words, sorry, 8 letters can be arranged in 8 factorial ways, right? Means we have to consider this is 8p8, right? Is it? Yeah. So this is arrangement of 8 letters on taking all at a time. Okay. So that is 8 factorial ways we can do. Anybody is having doubt here why it is a 8 factorial? See, first position can be filled in 8 ways. Second one can be filled in 7 ways, 6 ways, 5, and so on. Till 2, 1. Okay. So that means 8 factorial ways. Okay. Now there is a condition given. So first condition given is if the first letter is a vowel, the first letter, if the first letter is vowel. Now tell me, I ask. So in your school, sequence and series has been done. Is it completed?
No, sir,
Anyone?
they just started it.
Just started? Okay, okay. Okay, we'll try to finish it fast. We'll see, we'll have some few extra classes of this mathematics. Okay. I'll ask Raghav to arrange. So do you guys, can you guys take classes on Sunday, online class? Is there anyone having problem in Sunday class? Class on Sunday? Who's this? Achha, you have LN class, right? Okay. Anyone else is having the trouble with this class? I mean, on Sunday. I just want to finish your syllabus, okay? Because we are running a little bit behind. I understand that. Okay, so if the first letter is vowel, how you will solve it? See, what letters you are having? M, A, L, E, N, K, O, V. How many vowels are there?
4. 4, sir.
1,
3, sir.
4. How? Who said 4?
No, sir, I read it as you last question. Sorry, sir.
So there are three vowels, right? A, E, O. So three vowels are there. So that means you have 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 positions, and it said that the first letter must be a vowel. So how many vowels are there? 3 vowels. So first letter can be arranged in 3 ways, right? 3P1 or yeah, 3P1 ways, isn't it? First letter. Sorry. And other 7 positions can be filled in 7 factorial ways, right? 7 into 6 into 5 into 4 into 3 into 2 into 1, right? And this is of course your 3. Either here it can be A, E or O, right? Yes. Okay, so for first position can be filled in 3 ways. Sorry. First position can be filled in 3 ways and this. So 3 into 7 factorial ways. Is that okay? Anybody is having doubt here? Anyone? Please tell me. See, only these type of problems are going to be there in your exam. Okay, no problem. Okay, let's move on to the second part of this question. So the second part says the relative positions of vowels and consonants remain unchanged. Okay, let me write it. Relative position of vowels and consonants remain unchanged. Understood this part? Anybody having trouble understanding this question? See, now what you have to find if the position is unchanged. The relative position is unchanged. Okay, how you will solve it? So the word given to you is MALENKOV. This is the word given. Where is your vowel? Here, 1, 2, and here. So second, fourth, and 7th position. So on this second, fourth, and 7th position, there will be vowel. Okay, and other positions it must be a consonant. How you will do that? Anyone tell me the answer and the explanation? It's really simple. The whatever we think that only. Just remember what's the meaning of NPR. This is arrangement of N jobs taking R jobs at a time. Yes, tell me. Nidhi? Kruti? Shri Kruti? Murli? What? Everyone left or what? You guys are having dinner without me. Who left? Hari, Jeffrey, Murli, Naveen, Srinidhi, Shri Kruti, Divya. What happened, you guys? Anyone please tell me the answer?
Second
Shreya?
question again.
Yes, Shreya, tell me. Anybody is having doubt understanding this problem? First tell me, I'll explain it again. Please tell me. See, this word is given, and there are 8 letters, right? That means there are 8 positions. The question is saying that how many ways we can arrange such that the relative position of vowel and consonant, such that at second, fourth, and seventh position, you will always have vowels, and at other positions, you will always have consonants. So there are 3 positions and 3 letters, right? And you have to fill all. So 3 positions, that means vowels.
Sir, 3
Vowel,
into 4, sir.
what?
Is it 3 into 4, sir? 12.
3 into 4. Why?
Sir, because we can change the vowels place alone 3 times, and then for the consonant 4 times. Sir.
Okay, okay. I think you are getting confused here. Okay. I understood what you are trying to say. Actually, you want to say 3 into 5.
Yeah,
But yeah, I got it.
sir, sorry.
Yeah, but still that is wrong. Let's see why it is wrong. See, vowels, there are 3 positions, right? 1, 2, 3 positions. And in this, you have to fill 3 vowels, either A, E, O, right? That means arrangement of vowels, 3 vowels, taking 3 at a time. All vowels you will take, right? Isn't it?
Yes, sir.
So 3P3 will be how much? 6, isn't it? 6 ways. Okay, now consonants. So remaining positions are how many? 1, 2, 3, 4, 5. 5 positions are there and 5 consonants. So 5 consonants can be arranged in 5 P5, right? How much will be that? That will be 5 factorial, right? So that is
Yes,
5
sir.
factorial is 120.
120. Yes. Sir.
So total arrangement will be how much? Multiply this. How much you are getting? 720. 720 ways it is possible. Now you must be asking, so why you multiplied here 3? Why not 3 factorial, right? See here, there is only one position left. Only one position you have to fill with three vowels. So 3P, only one position. We are having here, we are having 3 positions. So 3 vowels and 3 positions. That's why 3P3 we are doing here. 5 positions, 5 consonants. Got it? Anybody is having doubt here, understanding?
Understood.
Okay, okay. We'll do other more problems, don't worry. Again, now next part of this problem will be no vowels are together. So no 2 vowels are together. Yes. Now to solve this, see, vowels must not be together. That's what you have to understand. If vowels are not together, that means what? We have done a problem like this yesterday. I think this not that. Yeah, this is kind of that type of problem. But yeah, this question number 5. Okay, yesterday we have done this problem. And the word, if you are still want the word, which word we are talking about? So it is MALENKOV. What's the meaning of this word? Malenkov. It's some Russian word, it sounds like, right? Okay, anyway. Okay, okay, got it. Yeah, anybody please tell me the answer and how you will solve it. Yes, Nidhi? Nidhi, tell me the answer. Shri Kruti? Murli? Divya? All left? Is it? Is someone please tell me the answer, or please tell me if you haven't understood the problem.
Sir,
What you did?
I didn't understand.
Oh, so you have to tell me, no? See, till now, is it okay? Means till this part, is that okay?
Yes, sir, the previous one I solved.
The previous one?
I solved it. I can understand.
Okay, okay. So this problem you are not able to understand, the third part, right?
Yes, sir.
Okay. So two vowels are together. That means you have 1, 2, and 3 vowels, right? Now you have to make words like you have 8 vacant positions, right? 1, 2, 3, 4, 5, 6, 7, 8. 2 vowels, that means this A and E. Let's say these two will come together. Maybe in next one, A and O must come together. In the next one, O, E must come together. That's what the meaning of 2 vowels, right? It must be, it can be either here or here or here. It has to be together. It cannot, you cannot separate, or all the 3 vowels can be together. Let's say here like this, or maybe some arrangement can be like this. E, O, A. Got it? But it has to stick together, 2 vowels at least. Okay. Did you get this problem? Still no?
Yes, sir.
Okay. So this is what the meaning is. Vowels must stay together. See, if vowels has to be together, that means what? Or you can arrange the consonants, right? First, you can arrange all the 5 consonants, right? So 5 consonants can be arranged on 5 position in 5 factorial ways, right? So first, since all the vowels will stick together, let's first arrange the consonants. So of consonant, okay, among themselves means consonants. How we can arrange this? So 5 ways we can arrange the consonant, that is 120 ways. Okay. Now what you will do? See, there's let me draw 1, 2, 3, 4, 5, 6, 7, and let's say 8. 8 positions are here, right? Now let's say there's what these words. We have this first consonant. So let's say consonants are here: M, L, N, K, and let's say V. Okay, sorry, one more please. I'll erase it, don't worry. And KV. Okay, 1, 2, 1, 2, 1, 2, 3, 4, 5. These are the 5 consonants. Okay, now if the vowel, suppose let's say this position, this, or this, if the vowels are here or maybe after this, after B, if the vowels are here, that means they will never be together, right? If the vowels, this can be one of the arrangement of this consonants, right? This can be one of the arrangement of consonant, but if we have this arrangement, so what will happen? The vowels will never come together, right? Just a minute, somebody just. Okay, I'm sorry, I'm explaining wrong question to you. Sorry, my mistake, I'm really sorry. See, no two vowels will come together, right? That means vowels must not come together. So if there are 1, 2, and 3 vowels are there, right? Just start from the beginning. So 5, anyway, this 5 consonants can be arranged in 5 factorial ways. That is 120 ways. Now vowels must not come together. That means what positions are left beyond M? Either the vowels can be here, right? Here, or after this M, let's say L, this position M, what are the numbers? M, L, N, K, V. So vowels can be either here, or here, right? These are the position 1, 2, 3, 4, 5, 6 positions. These are the 6 positions where we can put vowels, so that the vowel should not come together. 2 vowels are not together. I read the wrong statement. So no 2 vowels must be together. That means it has to be either at 1, 2, 3, 4, 5, or 6. There are 6 possibilities to put vowels, right? Or shall I explain it from the beginning? That means this 6 positions can be filled with how many vowels? 1, 2, and 3 vowels we have. So here it can be filled in 6 ways. I mean 6, sorry. So 6 positions are there. So either of the 6 position, the first vowel can occupy any of the 6 position. The second vowel can occupy any of the 5 position, and the third vowel can occupy any of the 4 positions. So 6 into 5 into 4 will be how much? 30 into this. So 120, right? 120 ways we can arrange vowels, and 120 ways we can arrange the consonants. So total arrangement will be how much? So total arrangement will be how much? 120 into 120. So it is 120 square or 12 square, 144, 0. These many ways. If you have doubt, I'll explain it again. I'll just explain it again, okay? So the question is, 2 vowels must not be together. Okay. So the word given to us is M-A-L-E-N-K-O-V. Okay. And in this, we know there are 3 vowels. These are the 3 vowels. Okay. And 5 consonants. Now these 5 consonants can be arranged in 5 factorial ways, right? So that is 120 ways. Now what about vowel? It is given that the vowels must not stick together. So when it will not stick together? So in between there must be a constant. The vowel there must be a consonant after each vowel. consonants can stick together, right? Consonants can stick together, but vowels cannot stick together. So what will happen? So let's write all the consonants. So M, L, N, K, and V are the consonants, and only position left for a vowel. A vowel can be here, 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 or here. These are the positions a vowel can occupy. Okay, either it can be at last, here, here, or means there has to be a consonant in the middle. Okay, to separate these vowels. So how many positions are there? There are total of 6 positions. So the first vowel can be arranged in 6 ways. The first vowel you can put either here, 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 or here. So there are 6 ways to put a first vowel. Second vowel can be put, now 5 places are remaining, so 5 ways. And the third vowel can be put in 4 ways. Okay, so it can be totally all the vowels can be arranged in 120 ways. All right. Now, if now vowels can be arranged in 120 ways, and the consonants can also be arranged in 120 ways. So from your fundamental principle of calculation or multiplication, what we can write? Total number of words will be equal to 120 into 120. So that will be equal to 12 into 12 is 144, 0, 0. These many ways. Is this clear, or still you have doubt?
Yes, sir.
I corrected in the beginning. I made some mistake. I thought maybe we have to take 2 vowels at a time. So that can again be a question. Okay, you have to take 2 vowels at a time. We'll solve those type of problems as well. Okay, I suppose this one is clear to you all. Now fourth part of this problem is vowels may occupy odd places. Vowels may occupy odd places. So how many ways it can be arranged? See, you think like this. There are total 8 places. So first, third, fifth, and seventh are the odd places, right? Instead of may, write must. Okay, may to vowels must occupy odd places. See, just try to understand. There are 8 positions. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 positions, what are the odd positions? First, third, fifth, seventh, right? These are the odd positions. So you have 4 vacant places in which only vowel will be there. Okay, so okay, now solve it. It's a little bit like the above problem. Don't try to memorize it. Okay, just try to understand. There are 4 positions and you have 3 vowels. How you will arrange that? Yes, done. Murli? See, there are 4 positions, right? So in first position, out of these means 3 vowels can be arranged in this, either here in first position, it can be A, or what can be there? You can fill any of the 3, right? Just solve it, man. Solve it.
A,
yourself.
E, or O.
A, E, or O, right? So there are, okay. So these 3 vowels in the first position, in it can be put, right? In the third position also it can be put. Fifth, seventh. Do it. There are 4 places. In these 4 places, A can be here, 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 or here. Anywhere can be A. Anywhere can be O. Means if A can occupy 4 places, E can occupy how many places? Huh? Shreya?
3 places.
3 places. Then
4
A-
into 3 into 2, 144 ways, sir.
so in this is how many ways? 24, right?
One.
This
Yes,
vowels can be arranged in 24 ways, and consonants can be
Yes,
arranged
sir.
in 5 factorial ways, that is 120. Right? So total permutation will be how much? 24 into 120. That's it. Understood or not?
Yes, sir.
Clear, right? Means, see, there are 4 positions. In suppose take any vowel. It doesn't has to be A. You can take any vowel. I'm just taking example A. Like let's say you are taking E. So E can be filled either here, 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 or here. Any of the 4 positions you are filling with E. So E can go in 4 ways. Any of the 4 places E can occupy. Let's say E occupied this position. So E had 4 options, right, to fill up the place. So E occupied 4. Now A will have, now since E has occupied this position, so A can go here, here, or here, right? So A can go into 3 places. Now what is remaining? O. Let's say A occupied that position. Okay. Then O can go where? Either here or here, right? So O will have only 2 options to go. That's why 4 into 3 into 2 ways. Total of 24 ways. Understood? Yes or
Yes,
no?
sir.
Okay. So 24 ways, and of course the consonants can be arranged anywhere. 1, 2, 3, 4. I mean 5 factorial ways, right? Of course, because there are only 3 vowels. So I said E is occupying this, A is occupying this, and let's say O occupied this position. So how many positions are remaining? 5. So 5. Now the consonants can be arranged anywhere, right? It doesn't has to be odd even. It no matter for consonants. So that will be 5 factorial ways. So 120. So 24 into 120 is how much? So 224 into 24, 120. So
2880.
Yeah, 2880. Understood? Yes or no?
Yes,
Having
sir.
doubt? 5th.
No, sir.
Vowels always, now all the vowels are together. Vowels will remain together. Yes. Now, how you will solve this? Just start with the given information. What is the information given? That the word we know number of vowels, and we know we have to fill 8 positions, right? Okay. How you will proceed for this? See, you have 8 positions. You have 8 positions, and the vowels will stick together. Means if the vowel is here, it will be here and here. 3 vowels are there. So all 3 vowels will stick together. Anywhere it will go, it will be together. Right? The vowels will always remain together. Yes. See, if the vowels are remaining together, so all three vowels, let's say A, E, O, right? These are the three vowels. It will always be together and it will act as one letter. Right? Because it is always moving together. And you have another 5 positions. Right? You have this 3 letters all acting as one letter and other 5 positions. So how many positions are there now? There will be 1, 2, 3, 4, 5, 6 positions. Right? So 6 positions can be filled in how many ways? 6 ways or 6 factorial ways, that is 720 ways. Right? Now the vowel in itself can be arranged in 3 factorial ways, right? Isn't it? So either it can be A, O, E, or E, A, O, or A, E, O, like that. It can be arranged in how many ways? 3 factorial ways or 6 ways. Right? In itself, vowels can be arranged in itself in these ways, right? O, E, A. What else? O, A, E. What else is remaining? O, A. Okay.
EOA.
E, O, A, right? These are the 6 way in itself vowel can be arranged. Right? In itself, vowel can be arranged in 3 factorial ways because there are 3 3p3, right? That is 3 factorial. Because there are 3 positions and all you have to take, all positions you have to fill, you have 3 letters for it. Now here, what is happening? All these 3 will move together. Let's say you have another possibility will be what? Another possibility can be 1, 2, and 1, 2, 3, 4, 5, 6. Now these are the 6 consonant, but E, O, A, let's say they will always be together. So how many positions are there actually? 1, 2, 3, 4, 5, 6. There will always be 6 positions, and this can be arranged in 6 factorial ways, right? These all can be arranged in 6 factorial ways. So that is 720 ways. Now total permutation will be what? (720) into 6. How much will be that? 4320. These many ways. Anybody is having doubt here? Vowels are always together. Why it is 6 factorial and why 3 factorial? So I think you must have understood why it is 6 factorial. Anybody is having doubt? It's okay. It's okay. Let it out. Okay. Anybody is having doubt in this problem? 6 factorial ways. Do you guys solve problem in home? Any problem?
Sir, can you explain it once again, sir?
Yeah, please. I will explain, guys. Anybody else is having doubt? Murli is having doubt. See, there are total of how many positions? 8, right? 8 places are there. But it is said that all the vowels will always be together, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Total was 8 positions, but vowel will always be together. Let's say A, E, O. Either A, E, O will be here, or A, E, O will be here, or it can be like E, A, O. It can be here, anywhere it can be, but it will always be together. So it will act as one letter. Okay, instead of 3 different letters, it will act as one letter. Understood? Because it is sticking together. It is acting like one letter.
Yes.
Right? Like there is no bar, there is no separation between them. It is acting always like one. Inside, they can be arranged in 3 factorial ways that we have seen here, right? The arrangement of this can be changed, like this will become EOA, like that, right?
Yes, sir.
Okay, so that part is clear. And why? And that's why all the consonants are there, right? So consonants 1, 2, 3, 4, 5 consonants are there. But this all will act as one letter, the sixth letter. Okay. And this can be arranged in 6 factorial ways. Right? This all together, it can be arranged in 6 factorial ways.
Yes, sir.
And this can be arranged, this inside it can be arranged in 3 factorial ways. Okay. And totally how many ways it can be arranged? 6 factorial into 3 factorial. Right?
Yes, sir.
Again, we are going to fundamental principle of that is, if some job can be done in m ways and another job can be done in n ways. So we together, how many, if you multiply it, you will get total combination of jobs, total number of ways of jobs, right? So that's what principle we are using everywhere here. N depends upon m. Okay. When m is independent of n, that time we will add. But here it is not independent, isn't it? Yes. Is this clear, Murli, now?
Yes, sir. Understood, sir.
Okay, let's do, must be having some problems in NCERT. Okay, let's do question number 10 of NCERT. Exercise 7.3. Okay, in how many ways of the distinct permutation of the letters in the word Mississippi? Okay, MISSISSIPPI, Mississippi. Do the 4 I's not come together? That means there are 4 I's in Mississippi, right? These all 4 I's must not come together. Do it. Use the same concept. If 4 I's must not come together, that means in the middle of all 4 I's, what can be there? There can be other letters, right? Do it. Just give it a try. I'm sure you'll be able to do it. Okay, we haven't done, I think, this type of problem, right? Mississippi. Okay, I don't think I have taught you this method, Mississippi problem. This means when the repeated letters are there. So that means this is permutation of things, not all different. Okay. Till now we have done problems based on permutation of things which are all different. I'm sorry. Let me give you a theorem. Then we will study about this. So the theorem says, if P1 objects are of first kind, let's say P1 are the objects of first kind, okay, and P2 are the objects of second kind. So the total number of permutation of all the P1 plus P2 object is given by, so permutation of P1 plus P2 is given by P1 plus P2 factorial divided by P1 factorial, P2 factorial. Okay. So let's understand this using with the help of some examples. Let's use this question number 10 of your NCERT. Okay. So in Mississippi, okay, in Mississippi, There are total how many letters? 11 letters, right? There are total 11 letters, out of which M occurs once. I will occur 4 times. Okay. Now S occurs how many times? 4 times. And what else is there? P. Twice. 2 times. Okay. So total permutation will be will be 11 factorial upon 4 factorial multiplied by 4 factorial multiplied by 2 factorial multiplied by 1 factorial. Just try to understand this. Was the meaning of this? See, the thing is, either when you are writing Mississippi, I'll just understand, okay, what I'm trying to tell you. M is once, I, S. Let's say this is different. Let's say this is S1. Okay. This is S1. This is I1. S2, I2. Okay, fill S, S3, S4, MI, SSI, right? Sorry, my mistake. SSI, I3, P1, P2, I4. Okay, M occurs only once. Now you see, try to understand this thing. Even if you change the position of these two, will it affect the word? It will not affect the word, right? Even you put S3 here or S3 here, it will not affect the word. You put either even S4 or you put S2 here, it will not change the word, right? Isn't it? Similarly,
Yes, sir.
it goes with I, this 4I, if you interchange, it will not change the word, right? That's why we are dividing it by 4 factorial ways. So these can be arranged in 4 factorial ways. That's why we are dividing it by 4 factorial ways, because it is not going to affect the word, whether you are using it at any position. So 4 I's, it can be arranged in 4 factorial ways, right? That's why we have to divide. We have to eliminate those. That's why we are dividing it by 4 factorial ways. Similarly for S and all the letters P, you arrange this P here or here. Suppose you are making some word P, M, I, S, 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 I, and P. Okay, this is some word. Okay, even if you interchange P with this P with this P, it will not affect the word, right? So you have to eliminate those, the which is occurring twice or maybe n number of times. So we will try to eliminate this. That's why we are dividing it by these factorials. And this is the theorem. There is a proof of theorem. We can also go with the proof of theorem, but I don't think it is required as of now. I'll give you if you really want it. Okay, there is obviously there is a proof of this theorem. Okay, understood this thing?
Yes, sir.
So you'll just divide it by whatever repeated words are there. Just try to understand this. If repeated letters are there, just in total permutation, you just divide it by those words. That's how Mississippi, this problem it can be done. So what is problem question number 10? Now do question number 10. Now you'll be able to do. See here, I'm giving you just total permutation. What are the possible words? Okay, but in the question, I think so there is something different, right? Distinct permutations of the letter in Mississippi. Do 4 I's not come together? Now you have to find 4 I's that will not come together. You have got the total permutation, but here 4 I's can come together, no? 4 I's will come together. Okay, 4 I's will come together, but the arrangement of 4 I's can be anything. It can be here, this I can be here, this I can be here. So it doesn't matter. It will form the same word. In total permutation, all 4 I's are coming together, but you have to find such that 4 I's are not coming together. How you will do it? See how this problem can be done. See, first the total permutation we know. Total permutation we have done 11 factorial upon 4 factorial, 4 factorial, 2 factorial, right? This is the total permutation. Now in the word Mississippi, we can, it's difficult to find all 4 i's not together. So let's find out when all 4 i's will be together. So I, and M, S, 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 P, P. So these can be arranged anyway. This can be arranged anyway, but I must take together. So I will act as one letter. Okay, I will act all i's together. This whole set will act as one letter. And this is your how many letters? 1, 2, 3, 4, 5, 6, 7 letters. So total you have 8 letters. Okay, so 8 letters, 8 factorial divided by, now I is taking together. So it will be divided by, yeah.
Sir, I should.
Yeah, I should not be together. That's the problem we have to solve. First, we are calculating i's are together. I's are together. So if you subtract from total permutation, that means you'll get i's are not together. Okay. So if i's are not together, that will be equal to total permutation minus permutation of i's are together. Right. So total permutation is 11 factorial upon 4 factorial into 4 factorial into 2 factorial minus 8 factorial upon 4 factorial 2 factorial. Is this clear? Or anybody is having doubt? See, when we have to calculate when i's are not together. So what we did, we got the total permutation. It is easy to calculate. Again, i's are together is easy to calculate. We have done using this method, right? We'll take if it has to stick together, that means it will be one letter. If something has to stick together, that will become one letter. Okay, and we know to find how to find the permutation of this, right? So this will be total will be 8 letters. So 8 factorial. Now S is repeating how many times? 4 times, and P is repeating 2 times. So it will be 8 factorial upon 4 factorial 2 factorial. Here, this is the permutation of i's sticking together. Now i's not permutation of i's not sticking together will be total permutation minus permutation of i's sticking together. So that will be 11 factorial upon 4 factorial, 4 factorial, 2 factorial minus this. So this value is how much? This value is, wait, can anyone calculate this, or I'll use just the calculator? This will be 34650 minus, this is easy, 840. Okay, so this will be equal to 33810. All right. See this, though, even if you leave up to this, I'm sure they will give you marks. Hopefully they should give you marks, because this is the concept is required. And if you can calculate these also, these numbers, that will be better. So this is your permutation of i's not sticking together. Mississippi, right? Mississippi, when i's are not together, that will be equal to 33810 waves. Got it? Any doubt? Okay, let's solve one more problem based on this. Okay, let's solve one more problem. Whew. Okay, the word given to you is independence. Okay, the word given is independence. in how many ways you can arrange if, number one, the words start with P. First, you find out how many total number of arrangements are possible. Number one, total possible arrangement. Find out.
So it's 12 factorial by 3 factorial into 2 factorial into 4 factorial.
How?
Sir, the total number of letters in the numerator and then the how much of the letters which repeat their factorial in the denominator. So
Yes. Okay. Everyone got this? How many letters are there total? 12 letters are there, right?
yes, sir.
So 12 letters. So total possible arrangement will be, total permutation will be equal to 12 factorial divided by how many times I is occurring here? One time. So let's write 1 factorial, which is obviously 1. N, how many times? 1, 2, 3 times, right? 3 factorial. D, 1, 2, 2 times. So 2 factorial. E, 1, 2, 3, 4. 4 factorial. What else? P, right? P is only one time, no? 1 factorial. Is it?
Yes, sir, that's it.
So that will be your total possible permutation. What else I have left? C. C is also one time, so 1 factorial. So again, this will be your total possible permutation. So these are the total number of words that can be formed. Total number of words that can be formed. Because either you use this E here or here, the word will remain independence only, right? Either you here, anywhere you use, the word will remain independence, right? So similarly, that's why we have to eliminate those possibilities. Those arrangements we have to eliminate. That's why total number of words can be, these are the total numbers of words that can be formed. So this number will come out to be, I'm using calculator, so I'm sorry because I am not very good at calculation. 1663200. Okay, so this is the total possible number of words. Now the second part, find out the words start with P. Yes. See, if the letter has to start with P, what will happen? Tell me. So there are total of 12 positions, right? But in the first position, there will always be.
11 factorial.
Yeah, exactly. So remaining positions are how many? 11, right? Remaining are 11 positions. So how you can do that? In first position, it will always be 1. And this is 11 factorial. And what else? Repeated, you will just divide it. So 3, 2, 4. That's it, right? So if the letters start with P, you will divide it by, you will do it like this, isn't it? Third one. Anybody is having trouble understanding this part? So this number will be equal to 138600. Okay. See, first letter is always, see, there are total of 12 letters, 12 positions, but the first position will always be P. So first one we have fixed. Now there are 11 positions left. So 11 positions can be arranged in 11 factorial ways divided by repeated number of letters. So we see here that what E is repeating 4 times, okay, and 2 times we are D is repeating 2 times, and what else? D, and what else? N is repeating 3 times. So we divide it by 3, 2, and 4. Okay, so the third part is all the vowels never occur together. So vowels are not together. And the fourth part is words begin with I, words begin with what I said, I, and end in P. Okay, so these two you guys do as homework. And with this, you can finish your exercise. Exercise 7.3 is complete homework. I think you can finish this exercise. There will be no problem that you cannot solve in exercise 7.3. So with this, we are finishing permutations. There is one more type of permutation that is called circular permutation. We'll do in next class. Okay, that is your like arrangement of clock. Okay, in circular manner or that table. We'll do that one problem based on that. Okay. So thank you so much. I'll disconnect the call. Thank you. Bye.
Thank you, sir.
So please do exercise 7.3, okay? And
Okay,
these two
sir.
problems, please take as homework. The circular permutation, if there is question in exercise 7.3, please leave it. But if you want, you can do it. You can give it a try. Not much of a difference, just a little concept. And in next class, we'll do that and combinations. Okay. Thank you so much. Bye.
Okay, sir. Thank you, sir.
Thank you.